When you think about companies like Google, Microsoft, they built the whole stack, and so they're in a kind of unique situation in the sense that they are the complete owners of their infrastructure. And there are quite a lot of companies that have been born in the world of cloud. Hybrid cloud is about the idea that companies that may have substantial existing infrastructures want to take elements of these cloud technologies and leverage them while still working with their existing built infrastructures. And so now you start to have a kind of a mashup, your existing solution and cloud-based elements. Examples you can think about are the apps that we're all starting to find so useful. I flew out here with Delta. The Delta app is wired into the Delta infrastructure. I used to do some consulting for them. They haven't thrown that away. So that old transactional infrastructure is still at the core of Delta, and yet they have become quite a new age airline by leveraging cloud selectively and I think very effectively. And you can think of tons of examples of that if you go through them. So apps that we're starting to see now from the banking industry, airline industry, other kinds of players, very often are sort of pointing to a deeper kind of dependence that's emerging now on the cloud. And our panel is going to look at the positives and also at the negatives of this type of a hybrid cloud world. I want to tell you just a few words about an example that I'm working on that's scary, and because it's scary, hopefully it'll get you thinking a little bit about what this might mean for your organization. So in the past, I've done a lot of work on critical infrastructure systems. I built the software that ran the New York Stock Exchange for more than a decade. You never heard about outages in that period because they were self-healed. It was my software. I worked on the French air traffic control system, US Navy Aegis, and most recently I've been talking to the operators of the electric power grid, the bulk grid in the US Northeast. We're building an infrastructure that tries to leverage the cloud to do a cost-effective monitoring infrastructure to track the status of the regional power grid. This would be everything from New York State up to Canada. And so you have cloud elements which I don't have time to talk about in detail, although I'll be happy to over lunch, integrated with the existing SCADA control infrastructures. Now, can the power grid really depend upon the cloud? This is an interesting question if you think about it. It sounds like a chicken and egg question. And it gets you thinking about the essence of hybrid cloud. You want to leverage the scalability and the elasticity benefits of the cloud, and yet, on the other hand, we don't want to get into a situation where a cloud outage brings down the power grid. That would just be utterly unacceptable. So that's our challenge.
So I'm going to focus on one particular aspect of I think, the journey to hybrid, and that's the compute layer. Obviously, there are many different pieces. There's management, there's network, there's tons of parts to it, but I want to focus on the compute layer because sometimes it represents the most challenging layer when you think about a hybrid cloud application. Me first, I sort of pick up a little bit on what Jason pointed out when he talked about Microsoft's cloud journey, which is we are in a moment of transition even within cloud. If you think back to cloud, the first cloud really were those colo environments where you took your existing servers and racks that you owned, you put them in someone else's data center, they gave you power ports and plugs, but really you managed it actually in the exact same way you would if it was sitting in your own data center. You patched it, you upgraded it, you had somebody who came out and did hardware swaps. So really it was, you can think of it as the lowest level of virtualization. We're now at the point where we're really in this second wave of cloud, which is we operate in virtualized data centers. I now no longer own the hardware. I have an API that allows me to provision hardware and software on the fly, and that has tremendous benefits, clearly, we're all seeing. But fundamentally, the abstraction layer that you work at in that environment is still at the layer of a machine. What do? You provision a virtual machine. You provision virtual disks. So really, you've changed the where of your computing, but you really haven't fundamentally changed how you do computing. And if you look at the web scale companies, whether it's Facebook, Google, Twitter, one of the keys in our ability to be able to operate at the scale we do is that we build on systems that really are what we think of as a third wave of cloud, in that we don't think about machines. We operate at an abstraction layer of applications. And that allows us to have incredible flexibility. It allows us to build data services that go from 0 to 30,000 cores for 10 minutes and then back to 0. It enables a whole new way of working, and I really believe that the IT infrastructure of the not very distant future will look a lot more like what the hyperscale web companies do today than it does traditional IT infrastructure. I want to say, what does that mean? Well, if you think about that environment, what makes a good hybrid cloud? Obviously, risk management is a big part of that. Migrations like going to the cloud are inherently risky. Their first order of business is, how do I de-risk that as much as possible? How do I minimize vendor risk in case I love my cloud vendor today, but what if they do something 3 years from now that I'm deeply unhappy with? Do I have off-ramps from my cloud vendor, not just on-ramps? Of course, having future-proof infrastructure, as Jason pointed out, is critical. But you also want to be thinking about a cloud not just in terms of how it lifts your existing infrastructure today, but does it build a bridge to this third wave of cloud computing? Does it help you get access to these emerging cloud-native application development patterns? And of course, whatever you do in hybrid, everybody I talk to anyway, you're inherently thinking multi-cloud and open source. You want the ability to take that workload off of cloud vendor A if you're unhappy with them and move it to cloud vendor B. Everybody I talk to anyway is very acutely aware of avoiding the same lock-in patterns that happened in the traditional IT infrastructure, where you have a database vendor, even if you don't like them, you can't kick them out. It's too embedded in the system. Everybody I talk to looks at the cloud vendors like us and says, tell me how you give me off-ramps and not just on-ramps. And those are all critical attributes of cloud. I think there's two suboptimal approaches, if I use my engineering terminology. I think one is to try to just run identical software in your cloud environment and your on-prem environment. And the reason is, to build this sort of third wave of cloud, you build systems in a different way. You assume limitless networking capacity, and you don't have that in an on-prem environment. You assume that you can instantiate virtual machines in a minute. And even if you have an on-prem environment, you probably don't have the disk performance to do that. You assume that if you need 50,000 cores for 5 minutes, you can get them. And that's usually not true in an on-prem environment. So I think it's a tempting approach to try to say, I literally am going to run the identical software in both places, but I think it ultimately limits what you can do in the cloud side, which is not really where you want to be thinking. The other approach is you can build sort of abstraction layers that try to cross the clouds. And we've seen that. There's projects like OpenStack and some other ones. I think generally those have shown to be just inherently fragile because they're operating at the wrong abstraction level. You're trying to cover over compute, storage, networking of the different cloud providers, and that ends up being a very leaky, fragile abstraction. So if those aren't the right approaches, I want to plant an idea of what I think the right approach is. I think the right approach really embraces containers as a key technology. Containers are a way to raise the abstraction level so that your IT administrators, your developers, you are programming your applications at an application level. You are treating your infrastructure as just a big pool of compute. And you have software that automatically determines what machines and what tasks could be run on. At Google, no Google developer can identify what server any given job is running on. They just have a job that has to be run, and our infrastructure says, oh, it needs this much compute, this much RAM, this much disk. I'll find a place in the infrastructure to run it. I'll run it, and when it's done, I'll reclaim that space. We really virtualize the entire data center into one big computer. And what we're doing with others, like Microsoft, Red Hat, VMware, is really trying to bring that technology into the open source world so that you can use that same container-based technology in your data center, and it really opens up the flexibility so that your developers can build a test environment on their laptop, and you can deploy that to a high availability cluster without modification. You can run it on-prem, or you can run it in a hosted environment. You can run it on bare metal, or you can run it inside a virtual machine environment. And the key here is this is an API and a platform designed from the get-go to be multi-cloud and open source. So as you think about your journey to the cloud, I just want you to think about how you're currently thinking about your container-based strategy, because I really do believe that is an important key in how you get to the level of flexibility that you need for a cloud environment. And I think it's also an important part about how you can start this journey so that your IT infrastructure looks and has the same flexibility that the cloud companies have.
to me, the hybrid cloud market and the environment looks like a little bit the supermarket landscape in London. I'm from London, so this is what you get. And yes, I came all the way here to London, from London, to talk about supermarkets. I'm sorry, but so you have a bunch of different brands, okay? And there are some that are bigger than others and very much distributed across the territory in a better way than others, okay? So these are the top 3 ones, and they offer pretty much the same items for the most part. However, for the end user organizations, the end user consumer, in my analogy, they have some differences, okay? Some differentiation points. So for example, some consumers may think that Waitrose offers better quality for meat. Sainsbury offers a broader choice, so you can find items that are impossible to find in the other 2 or in others. And then Tesco maybe has a lower price for household items, for example. And then on top of this 3, beyond this 3, there are a bunch of much smaller supermarkets that are even more capillary in the distribution of the territory, things like Coast Cutter, where you don't find all the items that you want, but they are close to your eyes, close to your house, very, very close. So at the end of the day, you could just stick for one of them, but you end up using all of them. You end up relying on these 3 in a lot of situations because they have these 3 key points: best food in some specific categories, cheaper price in others, and broader choice in other cases. But because they are not always present close to your house, you also end up using more local supermarkets. So the whole environment is very rich in offering, despite all offering the same items, and you end up, unfortunately, was using all the 3. So what happens is that if you want to buy online, in the UK, there is a big culture about buying things, buying services online. You have to register for all the 3, okay? You go online, you register for all the 3, you put your credit card. Every time you want to buy something, you have to book the slot and all the other things. I'm sure in the US there is something similar, but I'm describing what I know very well. So the problem is that this is a major annoyance because you have to repeat the registration process 3 times. You have to decide where to buy one specific items according to what is the most convenient place, or the one that for sure has it, or the one that has the best quality. And so you have to repeat the same identical process 3 times. And on top of that, as I said, you may end up also going to the local supermarkets that are closer to you because it's raining, you don't want to wait, whatever is the reason. Okay? So all of this implies that there is a major inefficiency in terms of cost, financial cost, because you don't always go for the cheapest choice. You always have a major OPEX in terms of how much effort you put in doing your online grocery, okay? So what happens is that somebody came up with a brilliant idea. They created a broker, okay? So there is this online website, I just remove any reference to it, that offers you connection to all the 3 supermarkets, lets you decide what is the list of, lets you write down what is the list of items that you want to buy, and then tells you exactly where you're going to have the best choice, the cheaper price, and so on. And they claim that you can save up to 30%, okay, from this approach. And they offer a lot of other additional opportunities and perks in using them. So you might think, okay, everybody is using the broker. Just like in cloud computing, everybody is using a cloud service broker, which is absolutely not the case. Very few people use the service. Why? This is a key problem. Because on paper, this is a great solution, perfect tool to solve and address the variety that you have and give you the best possible financial option. But in reality, it's not. Nobody's using it. Why? Because there are a number of challenges from an end user standpoint that must be addressed and not being addressed in the proper way. This is true in the supermarket landscape. It's also true in the cloud services landscape. First of all, the key question, these are open questions for discussion. I didn't mean to provide an answer. We certainly can try and give my perspective on this, but I believe this is an interesting conversation to have all together. The first question is the broker a tool that is actually reducing the complexity or is increasing the complexity in the attempt to give you the most cost-effective solution or the best choice for what you're trying to accomplish? This is the most important part, okay? Number 2 question is, what I'm getting from the use of a broker is enough to justify its use. Because you, from a human standpoint, this is true, also true in cloud computing, okay? You have to fight, the broker has to fight with the brand awareness that exists around 3 big cloud service providers and a number of smaller ones. And so you need to convince the consumer, the end user organization, to work through the broker rather than go straight to the different providers, overcoming what is the big brand awareness that these providers created, which is incredibly hard to do. The only way to do it is to demonstrate that there is enough value to justify the switch. And so the last thing is, can the broker keep up the pace with the change that all the different supermarket providers are offering in terms of changing their catalog? This is incredibly hard to do, but it's the most trivial of the 3 problems. The first 2 are much bigger, and something that I would like to discuss.
So I thought today we'll talk about what is Verizon doing about why cloud, right? So when I think about cloud, until like February of last year, my job was to do like application development. I was the CIO for our Fios business. And then I was given the opportunity to come to our infrastructure role and change the developer experience. So thinking about cloud, so it's increased the speed of innovation for the developer community, increased time to value, and also increased the efficiency into the infrastructure. So the idea is going from ticket-driven physical infrastructure into elastic, programmable, software-defined infrastructure. And as you do this, there are key variables that play a key role into this. So your teams, the teams you have, play a key role. The types of workloads you're running. So is it IT workloads? So when you talk about IT, we have about a little bit over 1,000 applications written in all kind of languages and middleware and whatnot. Versus when you talk about like network functions, so this is all what Nokia and Ericsson and all these guys write. So historically, they would give us boxes with software and hardware, and now we're driving them to just give us software running on commodity hardware. Versus our product, we're building brand new greenfield product that can be built into a container right up front, right? And then the partners you have. So who do you want to partner with? Because this is a journey. It's not like 1 quarter effort. And so these are the 3 key variables that drive which strategy you take. So I thought today I'll talk about what we're doing in the IT space. So where we started going, so we had most of our environment, I would say 75% virtualized was with VMware, but we wanted to go into more programmatical ways. So an OpenStack was a key kind of go more into open source. So we used OpenStack. And again, because we wanted developers to think cloud native and think microservices, so we saw like Cloud Foundry is the one we embarked on. So we wanted to keep an open environment. So we stood up very quickly. I would say in 8 months, we stood up an OpenStack environment with Cloud Foundry, and then we started the migration. So migration is going well. Some applications are using OpenStack as is and VMs, but they have to orchestrate their own kind of application because OpenStack is by no means VMware from a resiliency perspective. And most of the applications are going into Cloud Foundry. But so far, we've done like 40 out of 1,000. So that journey was going, but it wasn't going as fast as you like it to be. We invested a lot into CI/CD automation, so that's going well as well. But then we said, okay, what's the other lever we need to pull to increase this innovation? So this is where we look at the public cloud. Today, the biggest opportunity was on our dev and test environments. So these are, we have multiple environments, and no matter how many environments you have, it's not enough. And the other problem is they're always 90% idle because you're not doing activities all the time. And it still takes, there is a ticketing process to get some of these environments because you're not still in the new stack. You still have to go to your VMware environment, and there are processes and budgets. And so we wanted to cut through all of this. And so we gave every director IDs into a public cloud. So we're talking to AWS, to Google, to Microsoft and Azure. And right now we're in the process of, lots of applications have moved already their environment into the public cloud. And the idea is have all of dev and test into public cloud, have production internally, and where we want to go is, today we scale for peak. So we have an iPhone launch, holiday season, we already have the scale internally. Where we want to go is, today we are already running in multiple data centers. So how do you get to a point where scale for regular load, and then we can spike into a public cloud for peak. So that's where we're going, and there are lots of tools that are available. But again, this has been a big journey. And the other key element here is everybody. So Amazon is, I would say, is like on top, but you see like Google and Microsoft are investing a lot into getting enterprise customers into their clouds, and there are lots of capabilities. So the idea is From an infrastructure perspective, we're focusing on how to set up the right account structure, the right billing, the right logging, security practices, and then make it up to the application teams to go and innovate. They can use it from the server all the way to Kubernetes clusters, to BigQuery, to Microsoft investing a lot into machine learning. So create an environment, because we have about 15,000 developers, and each team has different types of skills. And so this is the environment, the framework we're creating to increase the innovation and faster value creation. Some of the, I would say, results, you get program infrastructure, meaning instant and elastic. Public cloud meaning freedom to experiment and innovate. Also, it means unlimited environment. One of the biggest aha was, when you go to public cloud, you get a bill immediately for what you've used. So when you share that with the development team and say, this is your bill, they go and resize. However, when they're in the private cloud, they have all the environments because they paid for it up front, and it's sitting there, and nobody wants to lose anything. And even though we use Aptio to show them their application costs and all this other stuff, but nothing like getting a bill from AWS or Microsoft or Google. And then they immediately resize. And so you get instant flexibility, and they can immediately resize. And that's creating different type of culture and innovation. On the operations side, higher utilization equals lower cost, and automation work versus busy work. So the infrastructure team, their job now is not to process tickets from the application team. Their job is to build an automated infrastructure and not get in the way between the developers and developers getting access to the environment. So that's what we're driving towards. Also, public cloud, based on what I mentioned, cost keeps on going down. So this is the journey we're on. Again, the key challenges and opportunities, I would say, platforms are never mature, so you need to continuously partner, pick your strong partners, and you end up playing the integrator role, so you need to also invest in talent on your side. Realizing efficiencies, you have to, I would say, leveraging public cloud was a big ticket for us, and adoption rate, we've been, as you do all of this, we've do lots of hackathons and dojos and teach the teams how do we, that's how you accelerate the journey in terms of adopting these type of clouds.